Because like I know a half times a half is a fourth, but is it really a fourth? Are you sure it's
different?
not one? You know,
Yes.
like the first time around, it's fine. The first derivative, piece of cake. Second derivative, what's that?
Okay, so this is the same thing as 25 minus e to the 1/2. So to do our first derivative, we're doing product rule. So derivative of the first is 1 times the second plus the first times derivative of the second. So the 1/2 comes down, inside stays the same. Subtract 1 from the power, so 1/2 minus 1 is negative 1/2, times derivative of the inside, which is negative 1. So that gives me 25 minus e to the 1/2 minus 1/2 c 5 minus e to the negative 1/2.
Would it have affected it? Because when I did it originally the first time, I put z over 2.
No, that's fine. So second derivative. So first we start with the derivative of this term. So 1/2 comes down, inside stays the same. Subtract 1 from the power, times derivative of the inside. Minus. Now I'm doing the derivative of the second one. If you had a mistake, this is likely where it is because you have to subtract off this entire thing. And we're going to get a couple terms in here. So we have to treat this as a product rule. So derivative of 1/2 z or of z over 2 is just 1/2 25 minus v to the negative 1/2 plus the first derivative of the second. So negative 1/2 comes down, inside stays the same. Subtract 1 from the power, so it's now negative 3/2 times derivative of the inside is negative 1.
Is that times right? It's times negative 1?
Mm-hmm.
Where did I get the negative 1/2?
Exponent.
Oh, yeah, okay. Oh, never mind, I just did it.
Is that plus? So the 1/2 came up in front
Mm-hmm.
on the first, but where did the first part of the
Product rule. The first, and this is all the derivative of the second.
Yeah, but where did that first one go?
This is the derivative of the first. Derivative of 1/2 z is 1/2. Second
Oh,
one
and
stayed
then
the
yes,
same.
okay. For some reason I just wasn't even.
There's a lot of stuff.
Yeah, too many stuffs.
Okay, let's see what we've got here. So, this will give me a negative 1/2 times 25 minus z to the negative 1/2. If I distribute this negative, that's minus 1/2 times 25 minus z and 1/2. When I multiply these coefficients, I get a positive 1/4, but I'm distributing my negative, so minus 1/4 z 25 minus z negative 3/2.
Times five.
So why would we bracket at the top? Like, why
I'm
would
just
it just
showing-
go across?
Because you're subtracting this whole term, so I put a bracket so you remembered you have to subtract off everything.
So does that become negative 1?
Yes, these are like terms, so negative 1/2 plus negative 1/2 is negative 1. 25 minus z. 1/2. is my second derivative? I asked for the second derivative of 4. So if we think about this, a negative 1/2 is like saying the square root of that on the bottom, right? And I'm plugging in a 4. Minus 1/4. The z would be on the top. Square root 25 minus 4 cubed.
Is only the 4 cubed? Or is the whole thing?
No, the square root is
Okay.
Oh, I never rewrote that. Negative 3/2. I was really confused.
okay. So on the bottom, there are varying degrees of how much you might simplify this. I went all the way with mine. This problem is ugly enough that I probably would not take off if you didn't go as far as I did. If you cube this, that gives you a 21 radical 21. So on this problem, I would probably accept it at this point. I went ahead and got a common denominator and put them together, which is how I got my answer. So that's totally up to you, if you guys wanted to do that.
I still got the right answer, but I think I did it the wrong way. Originally.
Is there really a wrong way?
I don't know. Okay, so what I did originally was I did take it to z/2 instead of 1/2 z, and then I did the product rule. I mean,
Yeah,
the quotient
that's fine.
rule with that.
Yeah, you're not wrong.
Okay.
See? No, you can do it literally. There's no rules anymore.
Oh, there are rules.
You can do it however you want. You'll probably get the right
There's
answer.
lots of rules. Okay. Let's look at 16b. So, my function so I'm guessing if you asked about this one, you probably did quotient rule. And that certainly works. But we also did these before we ever had the quotient rule. You could bring it up as a -2 and do the product rule. What else could we do?
Just
You could redivide every term by x squared. There's only one thing on the bottom. If you did that, you get a 2x minus 3 plus 4 over x minus 5 over x squared. Or you could write that as 2x minus 3 plus 4x to the -1 minus 5x to the -2. I haven't changed anything yet. I've just simplified it. Now there's no need for doing a quotient rule. It's just a matter of the power rule. What's the derivative of 2x? 2. Minus, what's the derivative of 3? 0, so that goes away. Derivative of 4x to the -1. X to the -2. Negative 5x to the -2 would be positive 10 x to the -3. So that's how I had my answer written. If you did the product rule, you probably would have gotten 2x cubed minus 4x plus 10 over x cubed as your final answer. So just a matter of how you did it. And you guys know I'll accept either. C. So this is another one. We can do the quotient rule. We could multiply out the whole denominator.
Just change that little 2 to a -2.
And my 1 over t, can I write that as t to the -1?
And that's when you bring that to the top, it's 1 times that. Like 1 times, so then the 1 would just.
Right. But if it had been like a 4 on top, you would have a 4 out in front. So if I rewrite it this way, then it's just change. Exponent comes down, inside stays the same, subtract 1 from the power, times derivative of the inside. Derivative of t is 1, plus derivative of t to the negative 1 would be negative 2 to the negative 2.
Do you want to see this one here?
You can, you don't have to. So you could leave it like this. You could distribute the negative 2 through the last parenthesis. If you had done quotient rule, you would have it all as a fraction right now.
Someone really recently bring that to you, or you really just been okay? Just curious if you've just been nursing it all day.
No, I just got it last hour. So what would we have to do here? You can get a common denominator and put them together, or just do quotient rule twice. It's not going to matter. So I think I probably did quotient rule twice, but if you guys would rather get a common denominator and do it once, that's an option too. Do you guys have a preference? Okay. So if we go that route, what would we have to multiply the first one by?
3x.
And the second one?
1 minus x.
X minus 1.
Yep.
Okay, so we get 3x squared. I'm going to go ahead and multiply out the denominator. Not that you have to, but otherwise we'll end up doing a product rule within our quotient rule, which is probably not real nice. So that gives me 4x squared to the 4th, sorry. No, 4x squared, my goodness, minus 1. Start multiplying. Over 3x squared minus 3x. And then you can do quotient rule.
Why there's no x on the first denominator? It's just 3 squared minus 3. There. Like in that second term there. Okay.
I was like, where
I
are
was
we?
like, what?
So low. D high, what's the derivative at the top?
8x minus 0. 8x.
Minus high. D low, derivative at the bottom?
6x minus 3.
Over low. Squared. So we multiply the first two, then we FOIL with these. What would we do now?
Cancel.
So if I distribute this negative. Negative 24x cubed and positive 24x cubed cancel. Negative 24x squared plus 12x squared is negative 12x squared. Plus 6x minus 3. Okay, technically, we can simplify this.
Take a 3.
On the bottom, if you take out a 3, it's really coming out as a 3 squared. Because it's in this parenthesis. So when I divide everything by 3, it leaves a 3 times the x squared minus x squared. So the answer I originally gave is what you would do if you didn't get a common denominator. If you just worked through, did quotient rule twice. This is if you did get your common denominator first.
My pen was slow at the moment I got here.
Yeah. It's been in and out all day.
Thanks. learned, because I'm on like the Wi-Fi now on my phone and my iPad for all like this stuff because I need it one day and Amber just went on it. I learned that you cannot send text to Androids on our Wi-Fi. On the Wi-Fi I'm connected to internet. So doesn't work. I guess an iOS text fine, but how dare I try and text an Android?
That's weird. Alright, so first of all, a square root is like what power?
Okay.
A half. You could even write this as 3 to the t to the fifth, all to the negative 1/2, and that would be the easiest way to work through it. Then we just have to do chain rule. So exponent comes down, inside stays the same, subtract 1 from the power, times derivative of the inside. And then if I multiply that, just a negative 15 t squared over 2 times 3.
T squared. T to the fourth.
Yeah, I don't know where I got mine.
I did that too on my paper.
Really?
But I wasn't looking what you were doing.
So there's different ways of writing it, but this would be one option.
Did you guys hear the Sonic Boom today?
Mm-hmm.
I don't ever hear them in the building.
Oh, really?
Not in here.
Is that one okay? G.
And you can't multiply like you can, oh wait, I guess, never mind, because I forgot that's your power.
Yeah, if it weren't for the power, you could. We have x of t equals secant 3t over tangent 5t. So we do quotient rule. Well, so tangent 5t. D high. What is the derivative of secant?
Secant.
So the angle stays the same. That's really sloppy. Okay, so it's secant 3t, tangent 3t. But we have to do chain rule, so times the derivative of the inside is
Oh,
That's
3.
right.
I was like writing my negative. I was like, what do you mean? We need more.
minus high, d low. What's the derivative of tangent?
Secant squared.
Angle stays the same, times derivative of the inside is 5. Over low squared. So if we just pull our coefficients out, we get 3, tangent 5t, secant 3t, tangent 3t. Minus 5, secant 3t, secant squared 5t, over tangent squared.
Wait, why would the other one be?
Is that one okay?
This one on this one, the cosine squared x is the same as like cosine x around parentheses squared.
Yes.
Okay.
So cosine squared means this, sine cubed means this.
Cool.
So we have to do product rule and within that chain rule. So derivative of the first. So if I'm doing the derivative of this, the 2 comes down, inside stays the same. Subtract 1 from the power, so now it's just to the first, times derivative of the inside, derivative of cosine. Negative sine. So that's the derivative of the first times the second plus the first, derivative of the second. So the 3 comes down, inside stays the same, subtract 1 from the power, derivative of the inside. So now if we simplify, we have a 2 and we have a negative, so that's a negative 2. Cosine x. Sine times sine cubed will be sine to the 4th. Over here we have a 3. Cosine squared times cosine would be cosine cubed sine squared.
I was trying to do the derivative of the angle. I'm not quite sure how.
Well, derivative of x is 1.
Yeah. But I skipped the part where you did the derivative of cosine. So
Oh, minor.
just tiny setbacks, tiny setbacks.
Okay. This one. Did you keep it like this when you did your derivative, or did you take the 5/3?
I took the 5/3 on top and bottom.
Okay. So that would give us e to the 5/3 x
Sorry.
over 1 plus x squared to the 5/3. You didn't have to. You could keep it like it was written originally. We will get to the same point.
So the 5/3 won't go on the outside of e to the x.
You
Oh, wait,
can,
never
but
mind,
power
never
to a
mind.
power.
Oh, dang it! I was just reading it wrong because I wrote it as just like ex, not e
Oh,
to the x.
You did e times.
Just curious, that power on the x.
It's
on
a square. It's
Okay.
just sloppy.
I just couldn't.
I tried to pull like a stunt like you guys. When you write a number wrong, you just write over it and hope that I know what you mean. It doesn't work. Okay, so quotient rule. Low d high. Derivative of e to the power is still e to the power, but we have to do chain rule. So times the derivative of 5/3 x is 5/3. So that's low d high minus high d low. So derivative bottom. Exponent comes down. Inside stays the same. Subtract 1 from the power. All over low. Oh, times derivative of the inside. Right? Let's drop that. Over low squared. 5/3 squared becomes 10/3. Is everybody okay here? You'll notice we have 2 terms, and they all have this. So we can take out the smallest exponent, which is 2/3. 5/3 minus 2/3 is just 1. 10/3 minus 2/3 is 8/3. Okay. So I have a 5/3 1 plus x squared e to the 5/3 x.
Could you not multiply the 5/3 to the e to the 5/3 x?
I mean, you could write it. It's just going to be a coefficient. It won't change your exponent.
Yeah, but could I have both of them out?
Yeah. Multiplication can happen in any order. Here 5/3 times 2x would be 10/3 x. Here the 5/3 x. Okay. At the very least, what do I need to do here?
The fraction.
So if we can multiply by 3 on top and bottom. You could choose to do more. My answer, I had factored out the E. You don't necessarily have to, that's just an option. So you can leave it like this. Okay, lots of different equivalent answers we could have on that one. Any questions there? Let's look at 18B.
Can we real quick just like crash course the meaning of 17?
A derivative is a rate of change.
So that's just saying like it's changing over time.
So the C is f of r. So if I want the meaning of f prime of 10. So my rate is 10. C is the cost. Since it's a prime, is how the cost is changing. So I told you it was 1200. So since it's positive, right, $1,200 at 10% interest. No problem. Okay, so 18B. X to the 4 times x plus y equals y squared times 3x minus y. You're free to distribute, but it's not going to change anything. You're still going to have the same amount of work because we have to do product rule no matter what. So, derivative of the first, derivative of x to the 4th. Second one stays the same. Plus the first. Derivative of the second. Derivative of x is 1. Derivative of y. Over here. Derivative of the first. Derivative of y squared.
2y divided x.
Times the second. Plus the first. 2y squared times derivative of the second.
3 divided x.
3 minus divided x. So now multiply everything out. 4x to the 4th. Plus 4 x cubed y. Plus x to the 4th. Plus x to the 4th. dy dx. 6xy. dy dx. Minus 2y squared. dy dx. Plus 3y squared. Minus y squared dy dx. At this point, we have to regroup. Everything with dy dx needs to be on the same side of the equation. Everything without it on the other. So what I'm going to do is just bring over this 3y squared. And I'll subtract over my x to the 4th dy dx. Can I factor out dy dx at the same time?
Yep.
So the final step to get dy dx by itself is to divide. Two y squared and negative y squared, you could go ahead and, I guess, well, I haven't combined yet. You may have already combined them. Let me put everything together. You have a 5x to the 4th